those at all. Alright, so we're talking about exponential functions today. We're on number 2, which says explore the function y equals 2 to the x. Now, the good thing is we've already seen this. We have already plotted this graph, and we've seen somebody else do it on video. Alright, so what we're going to do is we're going to use the values that they give us, which are -2, -1, 0, 1, and 2. And we're going to find the associated y values, which we've already seen on video. So when we plugged in a -2 for x, what we get is 2 to the -2, which is really 1 over 2 squared, which is 1/4. So write a 1/4 right there, right small, put a little slash, 1/4. Alright? When x is -1, 2 to the -1 is really 2 to the 1 over 2 to the first, 1/2. 2 to the 0 is 1. Remember, any number raised to the 0 exponent is 1.
That's 2.
Alright? 2 to the first is 2. 2 squared is 4. Alright, now we've already seen this graph, so we're going to plot it just real quick. -2 up 1/4. -1 up 1/2. 0, 1. 1, 2, and 2, 4. And then draw your curve. Now, we learned that with our curve, we cannot cross that imaginary line called the asymptote. Y'all remember that? When I get really mad, I might say the asymptote. Okay? Alright. Not going to do that. Okay? That's not nice. It's not nice at all. Okay, so the asymptote, Jim, the asymptote is the line that you get closer to. You get closer and closer and closer and closer, but you cannot touch it. Alright? Now, we're going to answer these questions related to this curve. The first question we're going to answer is, what shape is this function? Now, it doesn't really have a shape. I don't even know what you would begin to call it, except maybe it looks kind of like a boomerang, right? And if you attach another side to it, like a corresponding side, if you kind of put one right here, it'd look kind of like a butterfly, right?
Yeah.
All right, so let's call it a wing. You can call it chicken wing if you want.
Chicken wing.
But we're just going to call it a wing. So when I say this is in the shape of a wing, you know what I'm talking about. Exponential function. All right? Part C. Does it have symmetry?
Yeah.
Now remember, axis of symmetry was used to cut the parabola in half. No. If you draw a line down through this, let's say the y-axis, is it going to cut this thing perfectly in half so that it can fold onto itself? No. So you say no. All right, y'all remember domain? Set of all x values? Now, no, answer this. What x values does this graph not touch? It goes on forever in one direction and forever in the other direction. Does it not touch any x values if it goes on forever? No, it touches them all. So here's how we write that. We do parentheses, negative infinity, comma, infinity, close parentheses. This is interval notation. Y'all remember that? Nod your head yes. We learned how to do this. All right, we also said that if it's from negative infinity to infinity, this is all real numbers.
And negative infinity.
Now, what was the symbol? Somebody said it. The symbol for all real numbers. Remember, this is what I would call my ranch. If I had a ranch, I'd call it the double bar R. Who said that? Very good. Double bar R is real.
Why would you call it double bar R?
Because that's real. Keeping it real.
So why you keep it real?
Because I like real.
You ain't gonna make money
Real
off
as
it.
opposed to fake. I don't like fake. All right, you see what you get. What you see is what you get. All right. E, what is the range? Now, the range is determined by the y values. Now, does this thing go down forever?
No.
Yes, it does, Josie. Very good. It goes down, listen, it goes down forever. But what can it not cross? The x-axis, which is a y value of 0. So it's going to get closer and closer and closer forever. It's just never going to touch it. But because it goes down forever, the minimum has a limit. I said that wrong. Because it can never touch 0 but gets closer to it, the limit is 0. So we would say open parentheses, 0, comma, infinity. The range goes from 0 to infinity. Does it include 0? No, because it can't touch the 0. That's why we have an open parentheses. All right? Does it have a maximum or a minimum? No, because it goes up forever and it goes down forever. No. Even though it has a limit of 0, that's not the minimum because it keeps getting closer to it. So we say no. Does the function have an x-intercept?
No.
No, it never crosses the x-axis. Therefore, it does not have a 0 of the function because it does not cross. This parent function, and this is going to be our parent, does not have an x-intercept. Some of these graphs will have an x-intercept, but this one doesn't because it's the parent, and we refer back to the parent. All right. Does the function have a y-intercept? Does it? Yes. What is it?
2.
No, it's 0, 1. So we'll just say yes. We don't have to write the coordinate. You can if you want to. It's a 1. All right. For what values of f of x, or is f of x, positive and negative? Now, f of x stands for the function or the graph. Does this graph ever touch any negative y values? No, does not. So, for what values is f of x positive? You can say for all values. It's positive for all values. All values of x. No matter what your x value is, the y value is going to be positive. Now, this is only true for the parent function, or mostly for the parent. There will be some other transformations where you will have some negative numbers, but not for the parent. Everything we're talking about the parent right now. All right, when is the function increasing or decreasing? Is this function ever decreasing?
Yeah.
No, because it's going up to the right.
Oh, yeah.
So it's never decreasing. So you can say it's increasing for negative infinity to infinity. Increasing from negative infinity to infinity. All right, describe the rate of change. What is rate of change? We talked about this last week. It's the slope. That's exactly right. So what is the slope? Do we know what the specific slope is for this curve? No, because it's changing. Describe the rate of change. Here's how we're going to describe it. It is positive.
It is positive, that's the answer.
Yep. That's all we're going to say. Because it's changing. It's a positive slope. So we don't know exactly what it is, but we can find the slope for any given x value, but we know for a fact that it's going to be positive. That's the general concept of slope in this case. All right, now we're going to graph a few of these things. We're going to start out by graphing these using the table, but we're going to end up by graphing these without a table. We're going to learn how to graph them based on their key features, the characteristics of the function, like we did with parabolas. All right, so let's start with number 3a right here. This says y equals 2 to the x plus 3. All right, we're going to use the same x values that we did before. So negative 2, negative 1, 0, 1, and 2, right? Small. All right, so let's think about this for a second. What's different about this function compared to the parent function? There's only one little difference. What is it? The plus 3. So that means whatever my y values were for the parent function, I'm just going to add 3 to those, right? So we don't even have to think. We just add 3 to the y values. So my first y value was 1/4. So what's 1/4 plus 3? 1/4 plus 3? 3 and 1/4. Write that down. 3 and 1/4. Write small. All right?
3 1/2.
3 and 1/2 is the next one.
4.
1 plus 3 is 4. 2 plus 3 is?
5, and that's it.
And then 4 plus 3 is?
8, or 10. 7.
7. You'll get it. One of these numbers. All right. So these are our values. Now look, this was not complicated. The only thing I did was add 3 to the original function. Julian, pay attention. So now when we graph this thing, we're going to graph them. Every point that we had on the original, we're just going to raise it up 3 units. So we'll have a point at -2, 3 and 1/4. -1, 3 and 1/2. 0, 4. 1, 5. And 2, 7. And then draw your curve. Now, be careful, because now your asymptote is different than it was before. It's in a different place. Tell me where the asymptote is now. In this graph, where is my asymptote? 1, 2, 3. Draw a dotted line at y equals 3 that represents your asymptote. This is very important. One of the very first things that I'm grading you on when I grade these things is if your asymptote's in the right place. If you can at least tell me where the asymptote is, then you have learned something. And that, when it comes to reading a graph, understanding the asymptote, man, you're really very close to being fully understanding what's going on. Now, notice that my asymptote went from y equals 0 to y equals 3. Why do you think that is? Why do you think my asymptote went from 0 to 3?
Because we added 3.
And thank you. We added 3. What do you call that?
Vertical.
Vertical. Say it loud.
Vertical.
Everybody say it.
Vertical.
Chicken shaft.
1, 2, 3.
Chicken.
Y'all are just brutal. Y'all are brutal. Y'all are brutal. All right. Vertical shift. It's a shift. All right. Let's go over to the next one. Now, Rudy. Yes, Rudy, I've got 2 to the x minus 4. Where do you think my asymptote's going to be?
The fourth line.
Where? Up or down?
-4.
Down, because it's minus 4. So go ahead and do your asymptote. It's very, very helpful to go ahead and put your asymptote, because if you do, you know at least where you're supposed to kind of be, where you are on the graph. All right, now we want to use the same x values. -2, -1, 0, 1, and 2. Now, right now we're graphing it using the table. But guys, the good thing is, once we learn how to do this, we're not going to need a table. All right, now, if I'm subtracting 4 from the original numbers, I should do 1/4 minus 4. What does that give me as a mixed number?
-4 1/4.
-3 and 3/4.
Huh?
1/4 minus 4. -3 and 3/4. 1/4 minus 4 is -3 and 3/4. Yes, it is. All right. What is 1/2 minus 4?
1/2. Well, you.
-3 1/2, right?
-3.5.
Okay. What is
Negative
1 minus 4?
or -3.
-3. What is 2 minus 4?
-2.
All right. What is 4 minus 4?
0.
Okay. So those are our coordinates. So now we're going to plot these. We're going to go to the left 2 and down 3 and 3/4. We're going to go to the left 1 and down 3 1/2. We're going to go down, at 0, we're going to go down 3. At 1, we're going to go down 2. And at 2, we're going to stay on the x-axis. So you see that your curve looks just like the original curve, but it's It's down 4 spaces, 4 units. Every one of these points got moved down 4 units from where it was before. See, this point right here was just above the x-axis. So 1, 2, 3, 4. This point was halfway up. 1, 2, 3, 4. And so on. I just took every one of my original points and moved them down 4 units. Is that hard to understand? No, that's what a vertical shift is. You take your original parent function points and move them up or down based on whatever you added or subtracted to that function. All right, now we're going to do the last one here, which is 2 to the x plus 1. We're going to use the same x values. -2, -1, 0, 1, and 2. All right, so going back to my original had a 1/4. So what's 1/4 plus 1? 1 and 1/4. All right, what is 1/2 plus 1? 1 and 1/2. What is 1 plus 1? 2. What is 2 plus 1?
3.
And what is 4 plus 1? So those are my new coordinates. Now tell me where my asymptote's going to be.
1.
At 1. Very good. Up 1 from the x-axis. Excellent. So if you know where the asymptote's supposed to be, you are well on your way to understanding what these graphs are supposed to look like. All right, so let's plot these points. Left 2, up 1 1/4. Left 2, up 1 1/2. 0, 2. 1, 3. 2, 5. And then draw your curve. And again, the curve looks exactly the same as our parent function because the only thing we changed was where it was up or down. We moved it up 1 unit. And all the points got moved up 1 unit. The asymptote went up 1 unit, and all the points of the graph went up 1 unit. Very simple concept.
This is so easy.
Now, look at number 4. All right, when we look at number 4 on this graph, we see that we are given these problems again. It says compare each of the following to its parent graph. How is it different? So I just want you to tell me what we did. For number 4, this first one here, what did we do?
You add 3 to negative.
So what does that tell you to do?
Add 3.
No, what does it tell you to do? What? That you just said it. Yes, you did. What? No, what does plus 3 tell you to do?
Add
Up 3. Up.
That's your after.
Okay.
A word.
What does minus 4 mean?
That's the A word.
Down 4.
Yeah, your asymptote, yes. You go down 4, you move your asymptote down 4. What does plus 1 mean?
Up 1. That's
Up
the
1.
word too.
Okay? Now, the next problems that you see here, the next graphs, those are all linear. We're not talking about linear functions right now. So let's X that out. X out the next part. We're only concentrating on the exponential part of this. All right, now turn the page. The back of this page, you need to label it number 2. Put a 2 at the top, just like this. All right, put a 2 at the top. Now, we see that number 6 says compare each of the following to its parent graph. These are all linear. Mark those out. We don't want to do that. But we do want to answer this question. What can you conclude about the following function, y equals f of x plus c?
It has a Y.
It's a vertical shift.
Thank you. It's a vertical shift.
Well, I told you something had it.
It is a vertical shift. How do we know? Look over on the wall.
That's the formula, dude.
That's the formula for vertical shift, yes. All right, now, look at number 7. This time, it says graph without using a table. Now, here's the thing. We are going to do this without a table, and I'm not going to make you use 5 points.
I can tell you where
I'm only going to make you use 2 points. Because if you know where your asymptote is, and you know that this is a growth function, because we've only dealt with growth functions so far, and you know where what I'm going to tell you is called the shift point, where you know that's supposed to be, You don't need 5 points to look at this sketch of this graph. I'm talking about a sketch now. It's not perfect. So let's start with A. Y equals 2 to the x minus 5. Okay, asymptote negative 5. Go ahead and do that. Down 5. 1, 2, 3, 4, 5. Draw your dotted line. Make sure you put it at 5. Negative 5. Okay, we did that. Now, if you refer back to the original function, where was the y-intercept for the parent function? Where was it? Everybody flip the page back to our first graph, and where is our y-intercept? What are the coordinates here?
0, 1.
0, 1. So our y-intercept is 1 unit above the asymptote. That's important. We're going to call that point the shift point. Now understand, guys, listen to me. It's very important. This point that is 1 unit above the asymptote on the y-axis is going to be our shift point, and it's going to be 1 unit above as long as our a value is 1 and our base is the same as it is, which is a 2. Well, actually, let me take that back. It's going to stay the same as long as the a value is 1. Is our a value 1 in these functions? Nod your head, yes. Yes. So, we are going to have a point that is 1 unit above the asymptote on the y-axis. Right here, we're going to call it our shift point. Write this to the left. The shift point is 1 unit above asymptote on y-axis. Now, this is very important, guys. I'm not going to have you write this down, but you need to know it. This is only when our a value is 1. That's all we're dealing with right now is an a value of 1. But when we start changing our a value, it's going to change the shift point location. All right, so we got 1 unit above the asymptote. That's one of our points. Now, is this a growth function? Nod your head, yes.
Yes.
Yes, it is, because my base is 2. 2 is greater than 1. So this thing's going to go up to the right. If you refer back to the original graph, notice that this 4th point was up 1, right 1. Guess what? As long as we don't change our a value, you're going to have another point that is up 1, right 1. As long as it's a growth function. If it was a decay function, it would be up 1, left 1. So here's how you draw this curve. Now, did I have more than 2 points? No. But do I see clearly what this graph is doing? Yes. It looks just like the original. I can see that those 2 points give me growth. I know this is growth. I have to know it's growth. If it's decay, would I put that point up 1, right 1? No. Why is that? Because what does the decay function do?
It goes down.
It goes down to the right instead of up to the right. So if it was a decay function, I would need my point over here instead of over here so that it would give me a down to the right look. All right, so there you go. Now, look at part B. Let's do the same thing. All right, what are we going to do with B? First thing we do, Ethan, is what?
Look at our asymptote.
Asymptote. I'm going to go up 2.
I told you.
Draw your asymptote. All right? Once I am there, up 2, I'm going to put my shift point 1 unit above the asymptote on the y-axis. It's my y-intercept.
Look at his fingers.
Now look, guys. How many times did I shift up?
1.
No.
Twice.
2. So, listen. I also moved my shift point up 2, right? And that puts me 1 unit above the asymptote. Now, where's my second point going to be?
2 units above that.
No. Up 1, right 1, right?
And the next one's going to be up 1.
Why is that? Because it's just like the parent function. The parent function has a point, guys. Now listen. Up 1, right 1. So does this. All right. Now, we're gonna do the rest of this side of this page as a homework assignment. Except for numbers 1B, you can mark out 1B, you can mark out 1C, and you can mark out 1E. But we're going to do all of the other problems on this thing.
Where you getting these numbers from?
I'm right.